In this video, we look at the examples of the product rule and look at the variety of problems from the textbook that can arise in this section. So what we know at this point, at this video, we know that how to do the power rule. And the power rule says that the derivative of some function x to the n is nx to the n minus 1. So for example there, the derivative of say 4x cubed is 4 times 3 times x to the 3 minus 1, which would be 4 times 3x squared, which would be 12x squared. Okay, and then we can extend that to derivatives for x cubed plus x plus 1, for example, and you can take the derivative of each piece. The derivative, because it was based on a limit, you can use the limit properties to get 12x squared. The derivative of x will be 1, and the derivative of 1 will be 0, so you would get 12x squared plus 1. So that's what we know at the power rule at this moment, and we're going to extend this power rule to help us answer questions about the product rule. We also know how to take the derivative of exponentials and the derivative of something of the form e to the ax, which will be a e to the ax. So for example there, we know that the derivative of e to the 2x is 2e to the 2x. Okay. We also know that the derivative of say 2 to the x is 2 to the x times the natural logarithm of 2. So these are things that we know from prior to this video. Okay. We now need to look at the product rule, which is a rule which tells you how to take the derivative of two functions that have been multiplied together. Okay, and in a previous video we showed that the product rule formula, the derivative of two functions multiplied by each other, is the first function multiplied by the derivative of the second plus the second function multiplied by the derivative of the first. Or you could have written g f prime plus f g prime. The goal here is that you're mixing the two functions f and g being multiplied by each other. But in the first part of the formula right here, one function does not have a derivative and the other function does have the derivative. And then when you go to the second part of the formula, the function f, one of the functions now doesn't have a derivative, but the other function g does have a derivative now. So you can do that in any order that you wish. Okay, so let's take that, what we can see on the screen here, okay, and show how to take the derivative with respect to x of x squared multiplied by e to the x. And the answer, let me warn you, is not 2x multiplied by e to the x. It is not equal to the derivative of the first function multiplied by the derivative of the second function. Okay, this is not what the answer is. Okay, we must use the product rule when two functions are being multiplied. So the correct answer is the first function, f, okay, multiplied by the derivative of the second function. And g is equal to e to the x, so g prime is also equal to e to the x. That's what we know from before. Okay. Now we need to add on. Okay, so I've done fg prime, therefore I must have to do f prime multiplied by g now. g is equal to e to the x, so I can just go ahead and fill in that blank. And f prime, since f was equal to x squared, f prime is equal to 2x via the power rule. So now we can put 2x in for f prime. And now we can see that the correct answer for the derivative with respect to x of x squared multiplied by e to the x is x squared e to the x plus 2x times e to the x. Okay. And if you wish, you can factor out the e to the x to get x squared plus 2x. Or you could even go one step further and factor out the x to get x plus 2. So this is correct, or this is correct. Any one of those three answers. Okay? So there's using the product rule. Okay? And how the correct way to use it. This is the incorrect way. This is the correct way. All right? So let's see what other kinds of questions can be asked at this point. Okay? You can be asked, for example, to compute the derivative, let's say, of this function. Okay? It is a multiplication. I have two functions being multiplied by each other. The function f, you can pick either one, but usually I let f of x be the first one that I see on the left. The function g is the second function, is e to the x. And then I just go ahead and take the functions f prime and g prime separately. The derivative of f will be 6x plus 5 via the power rule. And the derivative of g is e to the x, because that's how you take the derivative of an exponential. So now we know that we're being asked to find the derivative with respect to x of f times g. So this is just a very computational example. Right? And they're asking you to work out the formula f times g prime plus g times f prime. And f is equal to 3x squared plus 5x. G prime is e to the x. I'm seeing that here in my little table. And then I'll put the plus sign, which is here. G is equal to e to the x, and then I'll multiply by f prime, which is 6x plus 5. And we're going to call that problem done. The derivative of the function f times g. There's no need to simplify at this point because there's been nothing more asked of you in the problem except to find the derivative, and this is a perfectly good derivative. Okay? All right. Let's go to the next kind of question they could ask. Okay? Oops, sorry. Given what we have on the screen here, this one is not the derivative with the product rule, because it is not of the form f times g. Is it? Well, yes. Is it of the form f times g? At the moment, it looks like it's f divided by g. So, could we use the product rule? Right? So, on the surface, it doesn't look like it's possible. But with one pen stroke, e to the x, we can turn this into a multiplication problem. E to the x divided by x squared is the same thing as e to the x multiplied by what? X to the negative 2. Alright, and now we have two functions being multiplied by each other. So what we're remembering here is that the properties of exponents, 1 over x squared, the x squared can move to the numerator, can move to the upper part if it picks up a negative 2, if the exponent picks up a negative. Okay, and now we can use the product rule. The function f is e to the x. g prime is negative 2 x to the negative 2 plus 1 via the power rule, plus g is x to the negative 2 multiplied by the derivative of f right here. And f is e to the x, so the derivative is e to the x. So there our answer would be negative 2 x to the negative 1 times e to the x plus x to the negative 2 times e to the x. And you can factor out the e to the x. Okay. And if you wanted, you could put the x to the negative 1 back in the denominator as x to the 1, and x to the negative 2 is the same thing as 1 over x squared. Right, so all these have been very computational in nature. You've been given some sort of function f times g to take the derivative of, and you just have to show all the appropriate steps to do the derivative. Okay, very computational in nature. Here's a couple sneakier little questions. Okay, like this one, for example. And it's sneaky because it looks different. Okay, but it's actually, once you get the hang of these are pretty easy problems. Okay, so notice that you've been, in this problem number 53, you've been given a lot of information. All this information has been given to you. And you were also told that g of z, is f of z times h of z. And your goal is to find g prime of 3, where g of z is equal to f times capital H. And you need to find g prime. But g is the product of two functions, f and h. So g prime is the derivative with respect to z of g, which is f times h. So now we have our product rule kicking in. G prime is equal to f times h prime plus h times f prime. And then they wanted you to find g prime at 3, which means g prime at 3 for z. Okay? But you just put 3 in everywhere into the g prime formula. So that's f of 3, h prime of 3, plus h of 3 times f prime of 3. So this is g prime at z is equal to 3, which is exactly what they wanted us to find. And now we just don't know any of f of 3, h prime, h, or f prime. But now we get to use what was given to us. You were given that f of 3 was 5. So you can fill that into 5. H prime of 3 was 3. So 5 times 3. Then we need to add on. H of 3 was given to you as 1. So this is the kind of problem where we don't know what these functions are, but we do know their values at specific points. So 15 plus 4, which will be 19. So g prime of 3 should equal 19. Okay? And that's the kind of thing that can happen a lot. You can be given a table of values, or you can be given the specific values themselves, and you just have to keep in mind what you're given, the function. What kind of function is it? The function g is the product of two functions, which means that you need to use the product rule and then plug in the value that you're interested in and then use the given information here. Okay? So those are pretty typical product rule problems. The rest basically just comes down to practice. Right? And here are some more problems to practice. Okay? For example, this function could be a product rule because it's the same thing as x multiplied by e to the negative x, so you could use the product rule on it. This function is a product rule because it's f times g, where the function is t squared plus 3 and the function g is e to the t. Okay. This one is doable as a product rule because it's a function f times g. The function f is equal to x and g is equal to 2 to the x. So you have the ability to compute some of these derivatives using the product rule. And so would end this first video.